Chapter 9, Lesson 2, Piecewise Functions. A piecewise function is a function that is a combination of one or more functions. A lot of times you see this in everyday life without even knowing it. One example would be movie tickets. In this piecewise function, it says for ages 0 to 12, the price of a ticket is $5. 13 through 54, the price is $9, and 55 plus is $6.50. So if I were to graph this piecewise function, on the bottom of my graph, I'm going to put my age. And I'm going to go by fives for this. And on the side, I'm going to put price, or money. I'm just going to go as is. My age from 0 to 12 is $5. That means if I go up to $5, I'm going to put a straight line and an open circle. This open circle says it goes all the way up to 12. Once you hit over 12, you pay more money. From 13 to 54, it's $9. So at $9, it's going to be a closed circle because 13 is included in this value, the 54. So almost 55, but not quite there. So I have to have an open circle at 55 because it is not included. If the value is not included, you always have to have an open circle. And then 55 plus, it's $6.50. So it'd be a closed circle because 55 is included in this value and straight across. Now this is a function. The reason being, whenever you want to test to see if something is a function, you do your vertical line test. If that vertical line goes through more than one point, it is not a function. If I were to draw a vertical line right here, it looks like this vertical line goes through more than one point. But since at $9 it is a closed circle, and at $5 it is an open circle, it is only going through one point at that location at 13 of age. And same thing for at 55 of age. You have an open circle and a closed circle. So that means it's only going through the point of $6.50 per ticket. So whenever you do your vertical line test, if there's an open circle, that means it is not including that value. Just how we also graph inequalities. Open circle, not including that value. Closed circle, including that value. I have to create a table and write a verbal description for the graph below. Well, I have two things here. I have the Gulf Green fee, and I also have times that changes the fee. So what I'm going to do first is write out the different fees that the Gulf Green has. It looks like each spot is going up by 3. So my first fee, it looks like it could be about $28. My second fee is $24. And my third fee is $12. I got that by looking at the Y values to see the green fees. the times. The first time would be from 8 a.m., that's where the line starts, to noon. So if I come in at noon, I know I will be paying $24 because this is an open circle. So $24 would be from noon to 4. And if I came right at 4, I would be paying $12 because this is a closed circle. So from 4 to close, I will pay $12. That's my graph. I also have to write a verbal description. Now, for a lot of you, this is going to seem tedious, but you have to do it. My verbal description would include green fees from 8 a.m. to noon are $28. From noon to 4 p.m. are $24. And from 4 to close are $12. So the hardest thing here is trying to figure out your opened and closed circles. Now, just like how we see this on a regular basis, the math behind it is if I was given a piecewise function like this. That means I have different y values for the different x values. I want to evaluate the piecewise function for x equals -2 and x equals 5. The first thing I have to do is look at the if x is what is y. So my first value is x is -2. So I look over on the if section. This says if x is less than 0, then my y will be -5. Since -2 is less than 0, my y has to be equal to -5. My second problem is if x is equal to 5. So 5 is not less than 0, so it can't be the first one. 5 is not in between 0 and 3, so it can't be the second one. And 5 is greater than 3. So that means my y value will have to be 12. Now I'd like you to try the second one by yourself. If you can. So I'm still looking at x is -2 and x is 5. So for the first one, x is less than 5. So -2 is less than 5. So I use the first equation. So my first equation is 3, and instead of writing x, my x was given, it was -2 plus 4. 3 times -2 will give me -6, plus 4 will give me -2. So this would be my first answer for when x is equal to -2. Now if I look at what x is equal to 5, this second equation here, it says x is greater than 5 or equal to. Since this has the or equal to line, I have to use my second equation. So my second equation, instead of writing x is given as 5, it'd be x squared minus 3. 5 squared is 25, minus 3 will give me 22. So that would be my second answer. So I want to evaluate each piecewise function for x is equal to -1 and x is equal to 3. For my function of x, function of f of x is equal to negative 1. If I look at my first equation, negative 1 is not less than negative 3, so it's not going to be that one. Negative 1 is in between negative 3 and 6. So I'm using my second equation. So when x is equal to negative 1, it's telling me the exact number y is equal to 15. So I also want to evaluate x is equal to 3. 3 is not less than negative 3. Negative 3 is also in between negative 3 and 6. So when x is equal to 3, y is also equal to 15. This is like your example for 20 to 25-year-olds have to pay $30 and 26 and above have to pay 35. You can have two of the same y's for two of the same x's. Now for my function g of x for negative 1 and 3. Negative 1 is less than 0, so I have to use my first equation. So I have to first evaluate negative 1 at x. Negative 1 squared will give me a positive 1 times 3 will give me 3. And 3 plus 1 is 4. For x is equal to 3. 3 is not less than 0, so it's not going to be this first equation. 3 is greater than 0. So I have to use my second equation. So I have 5x is given as 3. 5 times 3 is 15. Subtract 2 would be 13. So you always have to look at your if statements. And where does the x lie in between? Now if I were to graph a piecewise function, what I'm going to do first is before I look at my if statements, I'm going to graph each one of these equations separately. My first equation that I'm going to graph is 3x plus 8. This is in the format y equals mx plus b. B is my y-intercept, so that means I'm going up 8. My slope is a positive 3. A positive 3 over 1 is the same thing as a negative 3 over negative 1. So I'm going to go down 3 and over 1. Down 3 and left 1. The reason why I'm doing this is because if I were to go up 3 and over 1, I would run out of room on my graph. Connect these points. My next equation is also in the format y equals mx plus b, but my plus b is plus 0. So that means my y-intercept is going to be at 0, 0. And my slope is a negative 2, positive 1. Down 2, right 1. I could also go up 2 and left 1. And connect these points. Now, x squared minus 3. You could make a table if you wish to do that. I'm going to graph x squared first. If I just graph x squared, my axis of symmetry is going to be the y-axis. If I do 1 squared, that would be 1. If I do 2 squared, that would be 4. If I do 3 squared, that would be 9. And since my axis of symmetry is the x-axis, the left-hand side is going to look the exact same as the right-hand side. So this is the graph of just x squared. Now if I have a subtract 3 on the out-hand side of the equation, that's going to move my equation down 3. So x squared minus 3 will look like this blue graph. When I'm graphing the whole piecewise function together, I have to see where are my points included and where are they not included. So I'm going to circle where they're included. Because this has or equals, that's included, and this is included. On my second equation, neither of my points are included, so I'll have to have open circles. My first equation is from negative infinity to negative 3. So I look at my red equation and I look at negative 3. When x is at negative 3, y is at negative 1. So I'm going to write at negative 3, y is at negative 1. And to make my new graph look like my red graph, I went down 3 to the left 1. Down 3, left 1. And this one's included, so it's a closed circle. For my green graph, it's in between the 2 points, negative 3 and 1. If I look at my green graph, at negative 3, my green graph is up 6. And at 1, my green graph is down 2. So I'm going to plot those 2 points, negative 3, 6, and 1, negative 2. I'm going to draw this line. The thing I have to change now, if I were to do my vertical line test, I would have not a function. So I have to make sure at the points x is negative 3 and x is 1, I have open circles, because it does not include negative 3 and 1 at those points. For my blue graph, I'm looking at my point 1. My blue graph is included at x is equal to 1, and it has a straight line up through the point 2, 1, and also through the point 3, 6. So I'm going to write those points for my blue graph. And extend my line. So if you notice that at the point 1, negative 2, it is a closed circle. It's not a closed circle because of the green graph. It is a closed circle because of the blue graph. So if for some reason the blue graph wouldn't have ended up at the point 1, negative 2, it would not have a closed circle at that point. So the closed circle at that point is because of the blue graph, not the green graph. So again, if I were to check my vertical line test at any point on this graph, it would be a function because it only goes through one point on that vertical line. Homework for Chapter 9, Lesson 2. It's page 666. Yes, I know what that number is from. 2 through 18, 42 through 45.